exactly opposite direction. So the vectors are said to be collinear if and only if they lie along the same line or they are parallel to each other. Next definition is, suppose these are three vectors A, B, C, they lie along the same line, so these are collinear vectors. Or if the vectors are parallel, then they are also called collinear vectors. Next is equal vectors. Two vectors, A vector and B vector, are said to be equal. Two vectors, A vector and B vector, are said to be equal if they have same magnitude, if they have same magnitude and direction, same magnitude and direction regardless of position of their initial point. Position of their initial point. Two vectors, A vector and B vector, are said to be initial if they have same magnitude and direction regardless of the position of their initial point. अगर उनका मैग्नीट्यूड और डायरेक्शन सेम है, पोजीशन डिफरेंट भी हो इनिशियल पॉइंट की, सपोज दिस इज ए वेक्टर और बी वेक्टर स्टार्ट्स फ्रॉम हियर, if the magnitude is equal and direction is same, then these two vectors are said to be equal vectors. Next is negative of a vector. Negative of a vector. A vector whose magnitude is same, a vector whose magnitude is same as that of other vector, but direction is opposite to that of it. Vector, but direction is opposite to that, then these vectors are called negative vector. Let this is vector A and this is vector B. These have same magnitude but direction is opposite, therefore these are called negative vectors. A vector is equals to negative of B vector. Note it down. After types, next topic is addition of vectors. We can add vectors or we can subtract that. Addition of vectors by triangle law of vector addition. And next is parallelogram of law of vector additions. In triangle law of vector addition, when two vectors are represented by two sides of a then the total distance covered by the girl is AC vector, that is equals to AB vector plus BC vector. So this is the resultant vector, AB plus BC, that is equals to AC vector. I am again repeating the definition of triangle law. When two vectors are represented by two sides of triangle in magnitude and direction taken in same order, then the third side of triangle represents magnitude and direction is the resultant vector. Now next is parallelogram law of vector addition. It states that when two vectors are represented by when two vectors are represented by two adjacent sides of a parallelogram, when two vectors are represented by two adjacent sides of parallelogram by direction and magnitude, then resultant of these vectors is represented by diagonal of the parallelogram. I am again repeating. This law states that when two vectors are represented by two adjacent sides of parallelogram with same direction and magnitude, then the resultant of this vector is represented by the diagonal of the parallelogram. Now properties of vector addition. Vector addition is commutative, it is associative, and additive identity is 0. This is called additive identity. A vector plus 0 vector or 0 vector plus a vector, that is equals to a vector. 0 is called additive identity under addition for vectors. Now if lambda is any scalar, then lambda a vector magnitude is equals to magnitude of lambda into magnitude of a vector. Now next is components of a vector. Components of vector. Vectors OA, OB, OC. Vector OA, OB, OC, each having magnitude 1 unit. Write down. Vectors OA, OB and OC, each having magnitude 1 unit are called unit vectors along x, y and z axis. I am again repeating. Vectors OA, OB, OC, each having magnitude 1 unit are called unit vectors along OX, OY and OZ, respectively denoted by I cap, J cap and K cap. Let this is R vector, vector components. X, Y, Z are scalar components and xi, yj and zk. When the direction is also included with magnitude, then it represents vector. Now next one is vector joining two points. Vector joining two points. X, Y and Z. Let it be point P1 with coordinates x1, y1 and z1. This is P2 with coordinates x2, y2 and z2. Then the resultant vector OP2. P1, P2 is equals to OP2 minus OP1. So that is equals to x2 minus x1. So if we want to find the equation of vector joining two points, then that is equals to P1, P2 vector OP2 x2 minus OP1. x2 minus 0, y2 minus 0 and z2 minus 0, it remains same. So it becomes x2 minus x1 I cap. I component वाले एक साथ, j वाले और k वाले एक साथ. So x2 minus x1 I cap plus y2 minus y1 j cap plus z2 minus z1 k cap. Vector joining two points. Now next is section formula. Let P and Q, OP and OQ are two vectors. OP and OQ are two vectors. Let R divides OP and OQ internally. Let R divides OP and OQ internally. Then OR or R vector is equals to MB vector plus NA vector upon M plus N. Section formula: when two vectors are divided internally. When two vectors are divided externally, let this be OR, OQ, OP. Then if R divides two vectors externally, then R vector is equals to MB minus NA vector upon M minus N. This is the case when R divides PQ internally. And this is the case when R divides PQ externally. Now third case, when R is the midpoint of P and Q, then when R is midpoint of PQ, then R vector is equals to A vector plus B vector upon 2. Note it down. Now next is product of vectors. vector, theta is the angle between these two vectors. If A and B are two vectors, then dot product of these vectors is equals to magnitude of A, magnitude of B into cos theta, where theta is the angle between these two vectors. Now if either A vector is 0 or B vector is 0, then A dot B is 0 and cos theta is not defined in this case. Otherwise, theta lies between 0 to pi. Now why we have used cos theta here? Now when we have to multiply two vectors, then they should be in the same direction. But A vector is in this direction and B vector is going in this direction. So we make one point in the same direction by taking the angle of cos theta. That is why we have used cos theta here. Suppose this is A vector, this is B vector. Then B vector is equals to A vector cos theta. To make the direction same, we have take angle cos theta here. Now next is right angles. When two vectors are at right angles mean theta is 90 degree and cos 90 has value 0, so A dot B is 0. When two vectors are at right angle, then their dot product have value 0. When two vectors are at right angles to each other, then their dot product is 0. I dot I, J dot J and K dot K has value 1. I dot J, J dot K, K dot I or J dot I, K dot J and I dot K, these have values 0. If we see the properties of the scalar product A vector dot B vector plus C vector, that is equals to A vector dot B vector plus A vector dot C vector. Lambda A vector dot B vector, lambda A vector dot B vector, or we can write it as A vector dot lambda B vector. Now next is projection of one vector on the other vector. A and B are two vectors, then projection of vector A on vector B vector, that is equals to A vector dot B vector upon magnitude of that vector जिस पे की प्रोजेक्शन है. Projection of A vector on B vector, A vector dot B vector upon modulus of B vector.